Hello everyone, and in this video, we're going to be taking a look at a problem from the USAMTS, and it's a really nice geometry problem. So without further ado, here it is. Suppose you have a triangle FIG, and you have an arbitrary point D on the line segment FG. And then you construct the midpoints of FD and DG. I'll go ahead and call them M and N. And then you construct the lines through M perpendicular to FI and N perpendicular to IG, they intersect at a point T here. What we want to prove is that FT is equal to GT if and only if D is the foot of the altitude, so ID is perpendicular to FG. That's what we want to prove. So how can we get started on this problem? We're given a lot of these midpoints here, so we're motivated to take a homothency of scale 2 centered at D. And when we do, we end up drawing the perpendicular lines. So, and then we have another perpendicular line here. And let's call this point I prime. But since both of these are perpendicular, we know that both IFI prime and IGI prime are 90 degrees. The quadrilateral IFI prime G is cyclic. And moreover, I prime is the point diametrically opposite I on the circumcircle of IFG. For now, I'll just go ahead and denote it briefly as the I antipode, which means the point diametrically across. So that means that T is the midpoint of D I prime, where I prime is the I antipode. So as D varies on line FG, the point T moves along the line. So this line here. We want to find out when T lies on the perpendicular bisector of FG, because that's equivalent to FT equals TG. So if we construct a perpendicular bisector here, it only intersects at a point it only intersects once. So that means that D is unique. Thus, if we could show that the foot of the altitude satisfies the condition, we are set. Let's go ahead and draw that in. So that's the new point D. And we don't need the points M and N anymore. Alright, I've cleaned up the diagram a bit. So we've reduced it to the following problem. Suppose you have a triangle FIG and D is the foot of the altitude from I to FG. And I prime is the I antipode with respect to the circumcircle. And we construct the midpoint T of the line DI prime. And we want to prove is that FT equals GT. And we want to prove that ID perpendicular to FG implies FT equals GT. So how can we go about proving this? Well, the antipode and the altitude should immediately remind you of the reflecting the orthocenter lemma. And indeed, if we have the orthocenter over here, H, the midpoint of HI prime is just the midpoint of FG. So I'll just call it M. Sorry if it's a bit off-center. And moreover, the midpoint of the line II prime, by definition, is the circumcenter of the triangle. So hence, under homothency of scale 1/2 centered at I prime, the line IH, or ID on that matter, gets mapped to OM equals the perpendicular bisector, by definition of O. And in particular, the point D also gets mapped to the perpendicular bisector, so the midpoint of DI prime must lie on the perpendicular bisector. So we're done. The main tool we use to prove this problem is noting that D is unique and the reflecting the orthocenter lemma. So thank you so much for watching. I hope you enjoyed.